Hello 171 class, this is your notes for section 2.4, dividing, long division of polynomials, and then we're also going to use synthetic division later on. But long division of polynomials, it's very similar to long division of numbers. If you see these steps, especially the steps in bold, divide, multiply, subtract, bring down, that probably brings back painful memories when you were a kid. But it's very similar to that. It really is. So I'm going to show you an example with numbers and an example with a polynomial. Alright, now this is not meant to insult your intelligence or anything. This is again just to show you the parallels between the two. Alright, so when we're dividing, the number inside the box or the house or whatever you learn to call it, this number on the inside is called the dividend, and this number on the outside is called the divisor. Okay, and as we divide and we're putting numbers up here on the top, the number we put up here on the top is called the quotient. Okay, and you remember how to start. Like 13 won't go into 1, 13 does go into 14, and we put a 1 over the 4 to indicate that it's going into this place value. So 1 times 13 we multiply, and then we subtract, right? And then we get a 1 here. And then the bring down step means to bring down the next number. Right, and then 13 goes into 13 one time. Multiply, subtract. Right, there's nothing left to bring down. I get a remainder of 0. So there's the answer. Okay, so divide. 13 goes into 14 one time. Multiply. 1 times 13 is 13. Subtract. 14 minus 13 is 1. And bring down. Right. Bring down the 3, we get a 13. And then, if you notice, the next step is use this next expression as the dividend, repeat this process until the remainder can no longer be divided. Okay, and that's what we did here. Okay, it is the exact same thing as dividing numbers. Right, I used basically this exact same process to divide these two numbers. All right, now dividing a polynomial by another polynomial. Right, this is a quadratic by a line. If I'm dividing this by this, then this is the dividend. The dividend is the thing that we are dividing, and the divisor is the thing that we're dividing by. Now, what we do here is divide leading terms. Divide the first term in the dividend by the first term in the divisor. So all we're concerned with is x squared divided by x. We're not looking at this other stuff. Right? We're just x squared. X will go into x squared how many times? Or what number do I need to? What do I need to multiply x by to get x squared? I need to multiply by x. And just like we put the 1 here to indicate the first place we can divide is the tens place, we're going to do the same thing here. X will go into x squared, or x squared divided by x is x to the first, and so we're going to put the x over top of this x. Okay, so there's the division step. Now we multiply. X times x plus 3. Right, because it's got a sum, you got to think of it how you would multiply x times x plus 3 if it was written that way. So I'd distribute, and I'd have x squared. X times x is x squared. And then distribute the x through here, and you have x times 3 is 3x. Okay, so you're literally multiplying just as you would if it were left to right like that. Alright, so there's the multiplication step done. Now we subtract. Subtracting results in basically changing the signs of this thing. This is a positive x squared. I subtract, it becomes a negative. This is a positive 3x. When I subtract, it becomes a negative. And then these cancel. X squared minus x squared is 0. It should always cancel because we pick the number that goes here, or the expression. And then 4x minus 3x is 1x, or just x. Alright, so we subtracted. Now bring down the next. The next thing is a plus 3. Now bring down a plus 3. Alright, and then start over. Go back, and now divide this thing. So x goes into x one time, or what do I multiply x by to get this x? I multiply by 1. So positive 1 times x plus 3 is x plus 3. Right, and then subtract, change your signs. Right, and then I get a 0. There's nothing left to bring down. Right, I can't divide anymore. So there's my answer. Okay, I get a remainder of 0, so there's my answer. So x plus 1 is the quotient, x plus 3 is the divisor, x squared plus 4x plus 3 is also the dividend. Alright, so it's the same process, it's just a little bit more difficult in the subtraction step because you got, or multiplication and subtraction steps because you got polynomials, but the process is the exact same. Alright, also notice x squared plus 4x plus 3 is the same thing as, if I factor it, I put an x and x there, I need two numbers that multiply to 3 and add to 4, so that's going to be 3 and 1. And I'm dividing this thing by x plus 3. So those would cancel and I'm left with x plus 1. You could also have done it that way, but it's important that you understand this for when this thing won't factor, or if it's not a quadratic and you don't know how to factor it. Because long division will work for any expression. Okay, doing this technique right here will only work if this top is factorable, like that. Alright, and it's not always going to go cleanly, meaning you have a remainder of 0. And we have to be able to handle that as well. So if you get the long division step down, you won't be stuck if something won't factor, like it does in this case. Alright, something else I really want you to see here, to really emphasize that this is the same as what we just did with numbers. Notice this is a coefficient 1. This coefficient is 1. This coefficient is 1. So what I'm going to do is rewrite these numbers in blue that were in the division. And if you look, we got 1, 4, 3, 1, 3, and on the top 1, 1. Right, which is the exact same thing we just did here. I mean, it literally is the same exact thing. When you have whole numbers, single-digit whole numbers, and everything's positive here, literally is long division in numbers. It's not any different at all. Alright, let's practice another one. This is another one that would be factored that you could do by factoring. So, we're dividing this, so this is going inside the box. By x plus 9, that's going outside the box. So what do I need to multiply x by to get x squared? I multiply excuse me, by x. X times x is x squared. X times 9, 9x. Right. Change your signs to subtract. This goes away. 14x minus 9x is 5x. Bring down the next expression. Okay, and then what do I multiply x by to get 5x? Now I'm down here, I'm no longer up here in this problem. So what do I multiply x by to get 5x? I multiply it by a positive 5. 5 times x is 5x. 5 times 9 is 45. Right, and then subtract, meaning change your signs. So again, I get a 0. So x plus 5 is my answer. Once again, this one's factorable. X squared, I could write it as x plus 5 times x plus 9. X squared plus 14x plus 45 factors to this. Two numbers that multiply to 45 that add to 14. Right, and then we're dividing by x plus 9. So the x plus 5 is the answer. So you could have done this one by factoring too. But again, I want you to practice long division because it's going to be essential for the next couple of problems, next couple of examples, and then just doing stuff in the future. Alright, now this is a polynomial that's not in the standard form, the descending order. When we do long division, it's important to go back and rewrite those in descending order. So we're going to start off with the 6x cubed minus x squared minus 5x plus 4, right in descending order, and then when we divide by the 3x minus 2, everything's where it's supposed to be. We don't have it flip-flopped around. We're not dividing right to left like we're not used to. So write them all in descending order and then start your division. Alright, 3x goes into 6x cubed. What do I need to multiply 3 by to get to 6? I need 2. What do I need to multiply x by to get x cubed? I need an x squared. So this is where we're going to write it. So we need a 2 to go from 3 to 6. We need an x squared to go from x to x cubed. So 2x squared times 3x is 6x cubed. 2x squared times negative 2, that's 2 times negative 2 is negative 4x squared. Alright, and then change your sign, so this becomes a minus, this one will become a plus. Alright, these cancel. Negative x squared plus 4x squared is a positive 3x squared. Alright, and that's subtraction, so the next step would be bring down the next value. 3x squared minus 5x. What do I multiply 3x by to get 3x squared? I just need one more x, so I have positive x. Alright, x times 3x is 3x squared. X times negative 2 is negative 2x. Alright, change this to minus, change this to plus. Minus 5x plus 2x is minus 3x. And then bring down the 4. Alright, what do I multiply positive 3x by to get negative 3x? I multiply by negative 1. Negative 1 times positive 3 is negative 3x. A negative times a negative is a positive 2. Alright, and then when I change my signs here, I get a positive 3x, a negative 2. These cancel. 4 minus 2 is 2. Right now, there's nothing left to bring down. So what do I do? Well, think about what you do when you have something like 173 divided by 12. Alright, 12 goes into 17 one time. 17 minus 12 is 5. Bring down your 3. 12 goes into 53 4 times. 4 times 12 is 48. When I subtract, I get a 5. Now, what do I do here? What's the answer here? Well, we don't put the little r in the remainder division anymore. I mean, you did when you were a kid, but after that you started making a mixed number out of this. This was your whole number part. This was the numerator of the mixed number, and this was the denominator of the mixed number. Okay, and there's this understood, if you remember when you did mixed numbers, there's this understood, you didn't write it. There's a little plus sign between this. There's the whole number plus the fraction. Alright, so this is the same thing we're going to do here. We take our quotient, this polynomial, we write it first. Then we take our remainder, the sign of our remainder, which is positive in this case. We put a little plus sign because this is positive. If it were negative, we put a minus sign. And then we put the remainder over top of the divisor. Remainder over top of the divisor. So 2 over top of 3x minus 2. And there's our answer. So this is how we write the answer when we have a remainder with this long division.